In this problem, we are asked, given this function f of x, which is the square root of 3 minus 5x, to find the derivative using the definition. Again, whenever we are asked to use the definition, it's not acceptable to just use the any other derivation rules, okay? Then we need to find the domains of the function and the derivative, and then graph both of them on a common screen and compare with what we already found to see if it's reasonable. Okay, so for part A, we always start the same way. We write down the definition and see what happens. So limit as h tends to 0 of f of x plus h minus f of x divided by h. And we need to write the whole thing every time. Remember, we need to write the word limit, otherwise it's not correct. Okay, it's a little lengthy, but we have to do it. So square root of 3 minus 5 x plus 8 minus square root of 3 minus 5x divided by 8. Okay, and this limit, well, it's a 0 divided by 0, so it's an indetermination. So we need to figure it out. Because we have a difference of roots, we are going to multiply and divide by the conjugate. Remember, the conjugate is the same quantity, only we are changing the positive by a negative. Sorry, the negative by a positive. So let me copy paste. There we go. All right. And we didn't really do anything, but this changes things a lot, because now we can write again the whole thing, limit as h tends to 0. Then first the denominator. Whoops, let me copy the sum of square roots that goes in the denominator multiplied by 8, and then the numerator now is a sum times a difference. That's the difference of the squares, but the square of a square root is whatever is inside the square root minus 3 minus 5x. Okay, and now we are in business. Okay, because now we have 3 minus 5x minus 5h minus 3 plus 5x divided by 8 square root of 3 minus 5x plus 8 plus square root of 3 minus 5x. Okay, and now we cancel here. Remember, if you're doing a derivative by the definition and you reach this point and there is not a lot of cancellation, something is wrong. You need to go back and see that the computation is correct. Okay, and now the h's also cancel out. And I can take the limit because now there is no longer any indetermination here. And the limit as h tends to 0, the numerator is -5. And the denominator, as h tends to 0, the x plus h becomes x, and I have twice the square root of 3 minus 5x. And this is my formula for the derivative. Okay. Now the second part was asking to find the domains, right? So let me write down the two functions, and we go from there. 3 minus 5x. Okay, there we go. All right, so to find the domains, we only need to find the points where the functions have problems. So for f of x, we have a square root, okay? So we need 3 minus 5x, which is the inside of the square root, We need it to be non-negative. Okay? It's okay if it's 0. It's not okay if it's negative. So this means that x is less or equal than 3/5. Okay? So we can write the domain as the interval from negative infinity to 3/5 and then closed on the right. Okay, remember the negative infinity, always we write the round bracket, that means open on that side is unbounded. When we write the square bracket, means that that endpoint is included. So it's a closed interval. And then the domain of the derivative, very similar. We have a quotient and we have a square root, sorry. So what is inside of the square root is 3 minus 5x, which needs to be non-negative. But now notice that because we are dividing by that square root, the equality is not acceptable. Okay, now if 3 minus 5x equals 0, the denominator blows up. Okay, we divide by 0. Okay, so in this case, very similar, the domain is the open interval from negative infinity to 3/5. And that's it. Okay. On the last part is asking to graph both functions in the same axis and see how things look. So f of x, which is the square root of 3 minus 5x, f prime of x, which is negative 5 divided by twice square root of 3 minus 5x. Okay. Yeah. First of all, this function f has a 0, right? When x equals 3/5. So we display that. And then something else we know is that when we look at the derivative, clearly the derivative becomes vertical at that point, okay, because we are dividing by 0. So it will be either like this or like this. So which is which? Now here it helps to remember what is the domain. So the domain is on the left of 3/5. So then this option is not an option really. So we can erase it and our function is going to look something like this. Okay, that is our function f of x. And notice here I drew it so that it's clear that the slope becomes infinity at 3/5. Okay. And then for the derivative, let's use a different color coding here. There we go. So for the derivative, we need to realize that is going to become negative infinity. Okay, so it will go like this. But then when I take the limit of -5 divided by 2 square root of 3 minus 5x as x tends to negative infinity, okay, what is going to happen? So the denominator, we have the -5x because we are going x to negative infinity. That number is going to become infinity. Okay, so we are dividing by something larger and larger. So that is going to give a 0 limit. Okay, but notice that we are approaching from the negatives, okay, because these are negative quantities. So it will come somewhere like this, okay? And then looking at the function, there are no inflection points, nothing special about it. So we can just connect the two lines and it will look something like this, the graph of the derivative. Okay. And this completes the problem.